good morning and welcome everybody, all the speakers and attendees. My name is Inazio Martinez Arano. I am coordinator of the Bioregions facility of the European Forest Institute. We are a platform from region to region collaboration in the forest bioeconomy. We want to support regions' transition towards a sustainable development, to a greener and more bio-based economy. And we have several activities. We do policy changes. We try to understand what works in one region, give our regional stakeholders access to leading initiatives, networks, and knowledge. But we also try to speed up circulation of knowledge and the uptake of innovation. And this activity, this Forestry Speed Dating, is one of these activities to speed up knowledge uptake and innovations. How it works: our regional stakeholder has some thematic priorities, and then we invite innovators across Europe to present their solutions, and in this slide format online. So this works as we'll have 20-minute presentation from our speakers, and then we'll break out in rooms. We'll have opportunity to have a more direct contact, share contact details, and solve any doubts or propose any possible collaboration. So for a while we've been working on, well, just to say that in this effort we collaborate with Silo Future, the French competence center for forest and wood industries, and with Innova Wood, a fantastic network on linking research centers in, let's say, in wood processing in general. So we've been working in a series dedicated to bio-based buildings, so bio-based solutions for construction. So we're looking at timber buildings, but also we're looking at other bio-based solutions that can complement timber buildings and non-timber buildings. And today our speed is dedicated to let's say wood-based insulation. So maybe Siebe, you can introduce yourself and give some further explanation on how this event will work.
Yeah, okay. I'm Siebe. I'm a junior researcher at EFI's Bioregions facility. I'm mostly organizing these forestry speed dating events. So we will have the presentations from our two innovators. So Salvador Gilabert will present the IMIP project, and Antti Oksanen will present an innovation from the Passagão project. So both of them will have a block of 20 minutes to present, divided over presentation and few question and answers in the plenary. And after that, we will open 2 breakout rooms, one for each of the speakers, so you can further connect with both speakers and try to seek potential collaborations.
Great. Okay, thank you for this. So with no more hesitation, I will give the word to Salvador Gilabert. He's research director and technical director at the Politècnica University of Catalonia, and he will present his innovation on insulated panels based on natural cork and wood. So, Salvador, please, the floor is yours.
Okay, thank you. Good morning. Thank you, everybody. I'm Salvador Gilabert from UPC, Spain. And I would like to introduce you the IMIP project based on the interlocked modulars for construction based on low performance wood, but in really good new uses and increasing the performance by the new systems. So I would like to show the presentation. So yeah. I would like to introduce the IMIP project systems based in the modular insulation wood and cork for innovation in construction. So the partners are UPV, INIA, FCBA from France, ITIM from Spain, AAE from Spain, IBE, from Lisbon, Portugal, ISA, and UPC, and Silo Future in France. So we are a region from Southwest in Europe, and we have a really typical forest with a really not strong wood, but really easy to grow up. Is the Pinus maritimus, and based on this kind of Pinus that is usually used for this kind of industrial panels because of the performance of this timber is not really high, but we have a lot of let's say this kind of wood. So based on this reusing this material, we would like to, or we were developing, and we did, new construction systems that increase a lot the performance of this material, and it's really capable for the new systems in construction. So the idea was to evaluate this low performance good, designing use and a sectoral integration in this system with a really low environmental impact in a sustainable construction system compatible with a high energy efficiency, and that all these systems will be reusable and recyclable in this construction. So the developed systems that was done was, we can see in this table, a configuration in a parametric way with slabs, covers, walls, and sandwich system like a ship. And we have done a lot of different configuration in order to achieve a really big field of possibilities in the construction buildings. So we have the type D, that is this is the most typical one. It's CLT plus cork insulation for facades, even for a kind of covers. This is the most typical one, but the innovation is the uses of this low timber wood in the new, in this CLT, that the really input is that we achieve a really high performance with a really low cost, because this timber is really low cost. Then we have this sandwich that is a combination of a really thin CLT of 46 millimeters plus cork and plus other CLT that we achieve a really light covers for a lot of different combinations in the covers. Then we have this roof for a big span, like 6 or even 7 meters deep with this span, and we can achieve different combination, but mostly with granulate cork that is really cheap in Spain, Portugal, and south of France. Okay, then we have slabs, typical slabs, also arriving to a 7 meters span, even with granulated cork, but it can be used also with plants or of cork that we saw before. So with this, we achieve an innovation in a low performance wood composites boards to achieve a high performance boards. Constructed system based on a good and natural cork compatible with the traditional systems. All of the systems that we saw before is compatible with other ones that is in the market in traditional way, like bricks, concrete, or structure. But we can optimize, and we did optimization with a parametric configuration systems, and we can analyze in a real times with app web that we have done, and we are going to see pretty quickly. So we did the test with the mechanical resistance, and we can see how really easily we can arrive for kind of covers and slabs, even 7-8 meters of span, and even with these low or lower detail systems, we can go to good performance in different combinations for walls and even for covers. And to make a demonstration about it, we did 4 pilot actions, 2 buildings and 1 renovation, new buildings and 1 renovation project. So this is a test site for sustainable and renewable energies in Polytechnic of Valencia. So this pilot action is based on the systems that we saw before in the walls, the slabs, and the cover. That we saw before. We have spans of 7.5 meters, and is covering entirely by these systems. So all the project is done with these systems, and we are now under construction. The second one is this one that is a prototype that is assembling and disassembling. We can transport in really easily with the system of joining it between the different combinations of the construction systems. And this is a prototype that will use for emergencies like different combinations like small hospitals, etc. And the last one is a renovation with a combination of a different, for example, these different construction systems, old ones like these bricks that this is a reusable housing for poor people in a town hall in Valencia, close to, well, in Spain. And this is a good result of combination of different systems, but in making the introduction of IMIP details. Later on, we have done an app web that and this is another renovation, but extremely one that we are making a mix in between the whole system with ruins. And this combination is really easy to do because we prefabricated everything. We have all done, or at least in some parts, but all assembled in factory, and then we arrive to the plot and make the easy combination with the origin buildings or ruins or whatever. So for that we have, and for finishing, we have done an app web to analyze the high performance in terms of energy efficiency. So directly from the drawings of the project of the architects and engineers, from the BIM drawings, we pass it to an international and standard EFC export file, and from that, in our app web, we can analyze the energy efficiency, and directly we can achieve the certification of this project. So that means that in a really easy and really short time, we can analyze the project, and we can change the combination and the parametrics of these systems in order to improve or to control the better, or if necessary, to reduce a little bit the performance of our system. So this is a really useful tool. And then we can analyze also in the same time the carbon stick in this moment. This is the app web that we can control and see, and we have done all of these into the indicators of sustainable parameters, and analyzing all of the impact. We have achieved that in between 3 comparison systems, the green one is the regular one, the standard one with bricks or concrete. The red one is the one at intermediate system, and the blue one is our system. So this is the difference in between the environmental impacts from the typical construction systems or our IMIP systems based on this Cork and timber performance construction systems. And okay, this is my email. It's up to you to contact me if you have any question or any requirements or anything that you need. And we are open to prescriptors, designers, consultants, builders, etc., in order to clarify or to explain or to share information. So thank you so much. Thanks for your attention, and we are here for anything you need.
Looking at drivers for wood construction, and if we think, for example, I'm based now in Joensuu in North Karelia in Finland, and there is not much multi-story building being actually than on wood, despite being a strong forestry country. And one of the reasons is, of course, timber construction may be a bit more expensive, but it's also this question that there are no clear advantages of bio-based solutions over traditional buildings in terms of performance. So we can do things very well with wood, but we can also do them with let's say traditional construction. So my question for you is, you mentioned this is bio and low environmental impacts. Yes, you mentioned something about prefabrication as a key advantage that could be, but beyond that, what are the other, let's say, core advantages of this solution? Do you say it's high performing, but do you achieve better performance with lower thickness of insulation? What will be the key?
The performance is really similar, let's say, in order of the typical insulation, but the environmentals are really lower than the standard ones. But not only this is cheaper because the timber is cheaper. So this is the most important one. And we achieve a really high performance doing these combinations. And the other advantage is that you can prefabricate this and make a combination with other systems. Let's say you can have for, let's say, 10 stories high building, a typical steel structure or concrete structure in the primary structure, and then you have the secondary structure like slabs and covers with this system. But even if you want, you can do a 10 stories high with these systems using the detail of the CLT thick one.
Okay.
Or
so there is.
So it's possible. The good advantage in here is you have a lot of different combinations depending on how is your target or
Okay,
your.
so it's also structural element you can develop. You can use it as a structural and isolating element. And what about, have you tested, for example, noise behavior on, I don't know if you can use this in interiors, like aesthetics or noise or other conditions?
Yeah, this is a really good question. Thank you. I mean, we are now doing these last tests in FCBA in France. So we are finishing the test. We have to make the final control about it and to decide if we add insulated, sound insulated layers, like in the whole construction system in between these layers, for special performances or for special requirements of sound. It's true that it's a little lower performance in sound insulation than concrete, for example, in terms of impact. In terms of the sound on the earth is really good performance, but for the impact we have to achieve the special, I mean the complete kind of layers in the detail to can achieve the regulations.
And I don't know if our attendees know that Catalonia is producing roughly 60% of the world's champagne, prosecco, and cava stoppers. So there is cork residues there. But the question for you is also, what about used cork stoppers? That is quite a linear economy now. Can you use recycled cork, or do you need to use natural cork?
Okay, that's a good question too. Let's say, as you know, Spain and Portugal, we are, and even south of France, and we are really high producer of cork. But it's true that it's really completely recyclable in a different items like this champagne or taps, or even we can. I mean, we have different uses. No, for example, we have this, let's say, plate of cork, black one. But even if you have to remove the building for, I don't know, any question, you can reuse this, maybe making again the granulated one, because of in this granulated you can the performance of the insulation is exactly the same, and we used to do it for different filled cavities in a typical construction system, or even fill the cavities of the new IMIP systems, like we saw before, like slabs that are boxes and you can fill it up with this granulated core.
Okay.
After that is finally you can if you don't want to use it, you can do it for also for, I mean, if you don't want to use it for structure or insulation waste, you can use it for gardens. Later, you know, let's say 20 years later, you can do some composite if you need. So the product to product of this material is completely, you know, fully.
Fantastic. Yeah. We love Cork. Thank you for this, Salvador. Thank you for this. All participants will have the opportunity to meet Salvador in our breakout room after Antti Oksanen presentation. So let me introduce now Antti Oksanen. He is senior researcher at VTT, a fantastic research institution in Finland. And he's going to present an innovation on wood-based panels, so fiber panels for thermal building insulation. So please, Antti.
Okay, thanks, Inazio. So, okay, I will tell about our innovation that we have been developed in this Pasahoun project, and that's the reason why I have this Pasahoun template also in this presentation. So the innovation is this wood pulp panels, fiber panels for thermal building insulation, and I'm working in a technical research center of Finland, and I will tell very shortly about our company. Okay, next slide, please. Okay, here is a VTT in brief, and you can see that the turnover and the personnel number. So we are a bit over 2,000 people, and so this is research center, and so there's a lot of doctors and licentiates, and we are really international. So most of our projects are coming from abroad, like this EU project is very international. And next slide, please. And the kind of the core of VTT is what we are doing. We are piloting, so we are working, for example, with universities. They can do the fundamental studies, and they will come to us, and the companies will come us to kind of pilot their innovations. So we have different kind of innovations. For example, this Bioregions is kind of taking the extractives from the forest or from the wood, like lignins and that kind of things. And then we have electronics, and we can print on the webs and that kind of things. Very, very different areas. But there on the right side, you can see a pilot scale research environment for fiber processes. That's where I'm working, and that's in the middle of Finland. And so we have 2 pilots there, and those can be used for doing this kind of fiber products that I'm kind of presenting today. So next slide, please. And if you have any questions later on our piloting possibilities, then please contact me. And about this Pasahoun process, maybe there is someone who hasn't heard about it. So it's a sustainable wood construction for rural development and urban transformation. And the kind of coordinator is Technalia, and Javier Garcia Yaca is the leader. So that's quite big consortium, 29 partners, and the idea is there kind of to find wood-based innovations to maybe replace the kind of more CO2 emitting solutions at the moment, like concrete and steel, that is really influencing on the carbon emissions. And so next slide, please. So here's in one slide just demonstrating the Pasahoun projects that we are really looking from the forest to the actual building. So we are building a demo building there in the France border area at the moment, and so we are in this project. We are looking from the forest side, making new innovation with the wood-based materials, or replacing oil-based chemicals, making more sustainable composites, and facades replacing aluminium, and maybe some antimicrobial agents with more sustainable options. And one thing is what I'm going to present you is also this replacing, for example, glass wool insulation with more sustainable solution. And this is also something that you can ask later from the Technalia for me, or Oliver Janke, who's also online at the moment. So next slide, please. So let's go to the real topic of today. So about thermal insulation panel, and the need for this panel is kind of, if we are thinking about this, for example, glass wool, it's not easily recyclable, and it's not biodegradable, and so there is need for this kind of new, more sustainable material. And our solution is kind of what we have been doing. We are using simple wood pulp that is normally used in the paper or board mills to make paper or board and tissue and that kind of things. And then also this kind of panel needs to have certain technical requirements related to of course, the thermal insulation properties and fire resistance. So for our product, we have found that it has kind of same thermal conductivity as the current wood fiber-based insulation materials. We have tested that, and also it fulfills fire resistance requirements. So it could be used in the buildings. And of course, it's important that it's conveniently or easily installed, so it needs to be light and enough strength there. So this our technology to make this material foam forming enables that it's really light and still stiff, so it's quite easy to install, like you see in the picture on the right side, that it's really stiff. And next slide, please. So I mentioned the foam forming is kind of the core of this innovation. So that here is shown that in a lab scale how we can make this foam formed fiber panels. So it's basically we just form the fibers. We can form different kind of materials and the fibers, and it can be typical wood fibers or textile fibers. So keep in mind, if you have some kind of raw material and you would be interested to making from that, for example, cork that we saw in the previous presentation. So foam forming is really flexible, that you can use rather long fibers, and it doesn't need to be actually fibers at all. Can be fillers also. You can add the chemicals or whatever. And the benefits of foam forming compared to the conventional water forming is that you can get really even structures. Like on the right top side, there is a picture of bubbles. You can see the fibers are there in the middle of the fibers. So it keeps the particles separated and giving the very even structure. And yeah, you can see that we have been doing really thick samples, and it's working quite nicely. Next slide, please. And about our capabilities in VTT. So these pictures are from VTT Jyväskylä, where I'm located in the middle of Finland. We have 2 pilot lines there. We can do thin and thick samples, thicker fiber webs. So on the right well, here is only one of our pilots described, and the reason for that is this: with this one we can make a thicker samples for example, like insulation materials. So if you're kind of interested for using your materials or developing some kind of panels, we could kind of test it also here. Of course, there is some limitation how thick we can run in this pilot line, but yeah, we can come back to that later if you are interested. So this one uses the foam forming technology, and you can test the kind of materials in the dynamic pilot scale. And also multi-layer structures can be made this, so it can have different surface and different middle and background. So next slide, please. So in the Passahau projects, we made these panels, thermal insulation panels, and we made this in the frames. You can see in the middle there are the size of frames is 1200 times 600 millimeters. So that's kind of standard width, the 600 millimeter that is used in many insulation panels, at least in Finland at the moment. And so the process is like from the left, so that we mix the fibers and foaming agents together, and we get the very fluffy foam there. And after that, we place the fiber foam inside of the frame, and then just there is a dewatering, and then we dry the samples so that finally we make the fire retardant treatment. And so we have a lot of samples that we are going to test in the Passahau projects next, in Cubic in Spain, kind of Cubic test house in Tecnalia in Spain. And on the right side below is a picture of structures. Unfortunately, I couldn't share this. This would have been a video showing that we have also very nice capabilities to test technical properties like porous structures of the fiber network. So this picture is made with the X-ray microtomography device. So if you have some samples, we can look inside and make some analysis of the porosity, air flows, and everything. So it's not just piloting and making the samples. We can also of the kind of analysis of the samples. There's a question about oven drying. So that depends on the thickness of the samples and the drying. So in these tests, we have been using quite low drying temperature in the special ovens. Those have been really big chambers where we have been drying those. So it has been taking quite a long time still, something like 1 day or something. But it's a matter of in the upscaling, more like finding the right drying methods and in the dynamic way, using vacuums and in a way to remove the extra water fast. But in this case, we are still making these more semi-pilot scale, not in the dynamic way. Then with the drying time with oven drying is pretty long. But if we could use like a true air drying or blowing air naturally, it would be much faster in the kind of mill scale drying. Okay, next slide, please. So this is my final slide, and so we see that this pulp panels has great impact on our environment, so that it's based on natural wood fiber, and it means less special waste, and it could be used again, and or it could, I mean, as such also, but also it could be disintegrated and repulped, and you make this kind of insulation panel again. And of course, it stores greenhouse gases in buildings as a wood fiber. So why we are here? So it's kind of now it's time for upscaling, and we are looking for companies who would be or other instances who would be interested in upscaling and maybe manufacturing of this product. So we are a research center, so we are not going to produce the material. So in the projects we could help you in upscaling using our facilities in the lab scale and pilot scale, and so if you have some materials that you would be interesting to use as a thermal insulation panel, or you could use this fiber material that we have been using, then please contact me, and we can discuss further how to project continue in this area. Okay, so I think that was more or less. I don't need see. Maybe you can see that I have sample of our material here. So it's a really light and stiff fiber panel.
Thank you, Antti. Fantastic presentation. I saw there were some questions about biodegradability of the foaming agent and some more details on the drying period. Maybe you can address this as again, this circularity, degradability of a material.
Okay. Okay. Then if I remember, okay, as a foaming agent is used as a kind of typical detergents. So I mean, for example, SDS is used in the toothpaste, and this kind of chemicals that shouldn't be harmful for you. And of course, there are a lot of different kind of options for the foaming agents, so that could be screened. So yeah.
Okay. I have one question for you, Antti, before we break out in rooms. And the question is similar to I asked to Salvador. What is the key advantage for this product? Because you mentioned it has similar thermal properties. You mentioned that it's stiff, so maybe it's easier to use, or at least similarly used, easy to use. Is of course bio-based and maybe a low environmental footprint. But what would be the core advantage?
Yeah. There is, at least we didn't find at the moment any other which don't have at all kind of oil-based binders. They can use bi-component fibers, those more like plastic or other binders there, but our solution is just fibers there. So it comes from this foam forming technology, and I think that's kind of the key here. It can give good formation, but at the same time it's water. There is still water, so it gives good strength there in the consolidation phase of the material. So I think that it's glue-free is one of the benefits, greatest benefits here compared to the others.
Very good. Any other general question for Antti? What I see, Antti, is many of these bio-based solutions to gain market push, we need some sort of regulation in terms of requirements for sustainable construction. We need to really push the construction sector is very traditional, has a lot of inertia, and if we don't have a clear performance or price advantage, and it's just the environmental component, then we should regulate for that to get these products in the market. What do you think?
Yeah, exactly. Yeah, and I think, well, there are many activities and companies already invested in this material, and I think they have made their calculations that it should work also commercially. But in the Passahow project, I think there is also this kind of contacting of these legislators there already in the regarding the using of wood-based materials or that kind of things. So I think we should work in two phases, both phases.